Good afternoon. Thank you for joining us for Sampling with Confidence. Kurt Johnson, the Manager of Solutions Development with Automation Services, is going to walk us through how IDEA data analysis can be used to evaluate data and provide a better understanding of your complete data population. If you have any questions throughout the webcast, you may enter them in the questions box on the right side of your screen. We will answer all questions at the end of the webcast. We are recording, and we will send the recording out within a couple of days after the webcast is over. And the webcast slides are available as a handout in your GoToMeeting menu bar. Go ahead and take it away, Kurt.
All right, thank you, Lindsay. This is Sampling with Confidence, and we're going to be looking at some sampling issues today, and I'm going to demonstrate a little bit about what IDEA can do from a sampling perspective for you. So to start off with, let's say you're in Excel and you have, say, 100,000 items from your AP population, and you would like to sample from this population a number of items and be able to look at the control violations in the population, and also to see if the numerical invoice values that are being entered in the AP system are correct items. So one approach that one could go through in Excel would be to make a table of the data and then assign random numbers using the rand function, using copy-paste special with values to be able to get them to be static, sort numerically from top to bottom, and then you could copy and paste, say, the first 30 items from that, and you could have, say, a sample of 30. You picked a magic number of 30 because you remember back in statistics class somewhere between talking about t-distribution z's and central limit theorems, that somewhere way back somebody said that the magic number was 30, so you picked 30. So you come in here and you've picked your 30 items at random, and you've audited the 30 items for correctness. You've noted which ones are control violations and which ones aren't, and look to see, based on particular amounts that were observed, what the true audit amounts are versus what book entry amounts were entered, such as 70,000 as in the entry versus 50,000 as the true audit amount. So our objective here at this point is to say something about the population from such a sample. So we could perform some calculations. We noted that there were 2 out of 30 items had control violations. So we may conclude that the control deviation rate is 6.667%. And we could look to see, based on adding up the total dollar amounts for audit items and the total amounts for the invoice items, we could then perform a ratio of the audit amounts to the book entry dollar amounts, find that about 75% of the sample items were correct in terms of dollar amount, and our population of 105,000 items contained about $182 million of value dollar-wise. And so we could multiply one by the other and perhaps draw a conclusion that the population was overstated and should be adjusted to 138 million based on the findings in the sample. Okay. So now the question becomes then, how confident can we be in these projection numbers that we came up with based on our sample of 30? Well, if we were to flip over to IDEA, IDEA would be able to answer some of those questions for us. If we were doing attribute sampling for control violations, we could come in and say, well, we have a population size of 105,000. We selected 30 items. We found 2 deviations, and with 95% confidence, we could see what the projection would be of the control deviation rate that we observed, the 6.67%, to the population. And when we first may have concluded that maybe oh, the rate is only about 6 to 7% in the population. In fact, what we're finding is that the amount could be up to 22%, and maybe even or 19%. So we can't we can't have as much confidence in such a sample because of the size of the sample. If we were trying to, and that would be so we may not have as much confidence as we would have otherwise. We could also import that sample as shown here, and we could say, well, how about that ratio that we were looking at? So that ratio that we used, well, that's actually part of classical variable sampling. And we could come in here and evaluate the sample by putting in some factors. We have $35,000 of standard deviation, and our biggest value in the population was about 5 million. Once we do that, we can then make sure that our book entry amounts and audit amounts are correct. We want the invoice amount for the book value field, the audit amount. Okay, so we'll evaluate that with 95% confidence. And this will give us now something with that ratio estimator. That's what we call that in classical variable sampling. We call that the ratio estimator, where we take the ratio of the error found in the sample and apply it to the population, just like you saw me do in Excel. Now, if I can come here in IDEA and click on the data grid, we could see here where our most likely audited amount for the ratio estimator was at 138 million and change that we saw in the Excel file. What we didn't see in the Excel file, though, is the amount of error that could have occurred. Well, we said that the population should have been adjusted down by about $44 million. But with the only getting the 3 errors that we found in the sample, we look and we see, well, the estimated amount of error could be as low as $119 million of adjustment to a positive amount of $31 million. In other words, our finding of $44 million really meant little to nothing, because even though it looked like a good ratio, we only found 3 errors. And one of the big things that we find that we need to understand about certain issues of sampling, such as the application of the ratio estimator, is that it's not the size of the sample as much as it is the number of errors found. So let's go back and look at how we could construct a sample with confidence that would allow us to really project some good results. So based on what we saw there, we have 2 types of audit sampling that we want to be able to perform. We have attribute sampling, where we test for violations and controls. We also have monetary misstatement sampling, where we do monetary unit and classical variable sampling. And I'll present both of those methods. And our objective in all of these cases is to project the results back to the population. And, well, as you can see with the initial Excel example, anyone can pick a sample and go and audit the sample to get results. But how good are our point estimates or results that we get? These are based on the sample results. So how much confidence can we have in these? The point estimate accuracy depends on the size of the sample. And as we saw with the application of the ratio estimator, it's a classical variable sampling method. It also depends on the number of errors found. So, with classical variable sampling, you want to actually find somewhere around 30 errors, not necessarily just sample. So if you only sample 30 items, they would almost all have to have errors. In audit sampling, our planning is going to focus primarily on obtaining a sample that demonstrates the population error is below some materiality amount or percentage. Now, in determining sample size, if you go back to your statistics textbooks in college, things of that nature, you might see a formula like the one listed here. And basically, it's looking to take a proportion of the control violations, and this percent has to be between 30 and 70%. And it's going to put in this factor called T, which is usually 1.96 for 95% confidence levels. And one can assign some sort of percent width, D, for half of the confidence interval. Using this formula, if you were to know that control violations occurred 50% of the time in your population, how many sample items will we need to be 95% confident the sample will contain a control deviation rate somewhere between 45 and 55%? Well, in order to do that, we want P to be 0.5. T is going to be 2 for easy mathematical purposes, but it approximates this 1.96. And you want 5% on each side of the 50%. Plug those into the formula, and you get 400. So a sample of 400 would likely be representative enough of the control violations if you wanted to conduct a study of root causes of the violations. Now, this, of course, means as if you know what the control violation rate is already. And that's usually not the case when we're planning an audit sample. Usually we don't know what the control violation rate is. But let's say instead of actually finding a representative sample, we want to actually find a sample that will allow us to prove that control violations are less than 50% if they truly are. If the control violations did occur at, say, 50% half the time or higher, like with flipping a coin, you really wouldn't expect to have to sample or flip the coin 400 times to assess whether it really produces, control violations at a 50% rate. Let's say heads is a normal non-violation and tails is a control violation. So if you wanted to, but you didn't know this, what the true percentage is for what the coin gives you when you flip it. So you have to start flipping or sampling from the coin multiple times. If you wanted 95% assurance that the control violations rate or percentage of tails is going to be less than 50%, you actually would only need to flip the coin 5 times. Because if it was a fair coin, it would yield heads each time, only 3% of the time. So that's 1/2 times itself 5 times. Now, given that you don't know the true nature of the coin, if someone and tails, and you were betting that the control violations were 50% or higher, and meaning you would get tails, well, if that happened where someone flipped the coin 5 times, then you would find that you'd have diminishing evidence that the coin was fair. In fact, and if you wanted greater assurance, say 99% assurance, you could flip the coin another couple times, because there would be less than 1% chance that a coin that was fair and with a 50% control violation rate would actually give you no control violations if you were to sample 7 items. Furthermore, if you wanted 99.99% assurance, you could flip the coin 14 times. If you were a betting person and after 14 times the coin gave you heads every time, and you wanted to continue to bet on tails, you might have a gambling problem at that point, because you have a very, very unlikely chance that it's truly 50%. So this basic example leads us to how, the basic inputs for how we plan an audit sample. And what we do here is we look at something called tolerable error or misstatement, and we're looking at a materiality threshold and as a percentage or dollar amount that defines the sample's precision. Classical variable sampling uses desired precision as an input. And we want the sample to demonstrate that the population error is less than this critical amount. This is a critical amount input that you supply. The confidence level reflects your beta risk or sampling risk and provides assurance that your conclusion is correct. So 95% would be correct, your conclusions would be correct 95 out of 100 times if you conducted the sample study. So, and then there's finally the expected error. A lot of people talk about the expected error in the population. Well, what this really is the expected error in the sample. In monetary unit sampling and attribute sampling, this implicitly is used to control alpha risk, which is sometimes known as your risk of over-auditing. This is where we could get unlucky errors in the sample and concluding that there's material error when error is immaterial. Let's say you had 105,000 items in your population, and there was only one control violation in it. And you wanted to prove that the control violation rate was less than 50%. You should only need to sample 5 items. But if you sampled those 5 items and you got unlucky, and one of those items happened to contain the control violation, you would conclude wrongly that there was material error when there was not. So I'll show very quickly how we can use expected error to control for getting unlucky. And in classical variable sampling, we can use it in planning to assure that enough errors will be found in the sample. So we're going to flip back over to IDEA for a minute, and we can look with attribute sampling. Again, if we were to take that 105,000 items, and we had that textbook example, we computed that. This is how we get that 45 to 55% confidence level if we were to go that route. If we were to come here and do attribute sampling where we wanted to plan what we would need to sample with 95% confidence to prove that to get some provable idea of the control violation rate being less than 50%, we would only need to sample 5 items. And as long as all 5 items came up with no control violations, then we could conclude that with only sampling 5 items, that the population rate is not more than 50%. If we wanted to do a realistic study, because control violations generally are not 50%, they could be more like 5%. Then we can compute what the necessary sample size is for it. And if we were to sample 59 items, then with no items being control violations, then that would be a good sample for us. The expected deviation rate in the sample, however, if we were to expect some sort of error, we could plug in a percentage here. This would allow us to absorb a control violation, an unlucky one, in the sample if we were to sample 93 items, allowing us to pad the sample with more items in order to be able to absorb one of these unlucky ones. So if we were to go at that point, if we wanted to come and pull a random sample of, say, 93 items, we could come here, pull the random sample, and it's that quick with IDEA. Rather than making a table, assigning random numbers, doing copy and paste and some sorting, we can get the random sample very, very fast. We can, if we were to find that there were at that point the sample would have enough items such that if we were to now go and evaluate the sample and say of the 105,000 items, we had 2 deviations out of our 93, we could then compute and see that the actual number of projected control deviation items could be less than 7%, which is more along the lines of what we were hoping to prove. With a sample size of 30 was just simply not precise enough to give us that based on our earliest example. So the other thing we can do is we can do monetary misstatement sampling. So we could come in and based on the invoice amount, we could give it a confidence level, so we have a 5% sampling risk. And we said, well, we have about $182 million in our population. If we wanted to test whether the overall error is less than 5% or 9.1 million in the population, we could get a sample size of 59 again. And then we would be able to, and we could absorb, but of course the 59 would have to come back perfect. If we were to estimate it such that perhaps we expected some error in the sample of 72, then we could absorb a certain amount of tainting. Tainting is percentage difference of error. We're going to, between the book entry and audited amounts, we can then create a sample like so, and it'll give us our sample plus some high value items, and which are some of the bigger items in the population. We could then come over here and audit a few items for correctness and evaluate. Once we've done that, we can then get a projection of the total amount of error based on the precision of the sample, smaller samples being less precise. We up to $7.7 million, which is less than the $9.1 million that we were hoping to get under. So in this case, these two errors in the sample would pass. And we would use monetary unit sampling when we expect very few errors. One can also get an idea as to how the calculations are made for understatements, overstatements, and get a summary, as well as being able to project out to a PDF some of the results of the MUS evaluation. So moving quickly, we can come and say, well, if we're expecting a lot of errors, in monetary unit sampling being for if we have very few errors, let me cancel that. And we can go back to our population and do a quick preparation on invoice amount. We could stratify the sample, again with 95% confidence, and we're going to put in $18,200,000 of error, or 10% of the total amount, and 10% expected. This would lead us to the conclusion that we'd need a sample size of 211 to be able to employ the ratio estimator and other classical variable sampling methods, and that would allow us to extract a sample like shown, and where we could go in and change the audit amounts to the true amounts based on how we did the sample. In this case, since we're up against a short period of time, going to show you that I've already pre-selected 31 error items, and once we've done that, we can evaluate the sample, and it'll give us these items. And now we can see here finally that when we conclude that if the error is overstated and needs to be adjusted down, the population amount truly now no longer crosses the x-axis, right? We can now see here that we have it's at least $31,000 that we need to adjust down, and it could be adjusted down up to $977,000, because now we got enough errors and we got enough sample so that we could sample with confidence. All right, and that is pretty much it for what I wanted to show. Had some quick references to show here for what I used Are there any questions?
I do see one question, yes, Kurt. And thank you for sharing with us.
All righty. The question is there a way to use IDEA to pull a sample based on risk? As you know, IA, internal audit, perform risk-based audits. In IDEA, you can pull a sample based on the inputs that I showed. As far as your risk goes, you have two types of risk. You have your beta risk, and you have your alpha risk. And in attribute sampling, you control your alpha risk with your expected deviation rate, and you control your beta risk with your confidence level. There's also a more sophisticated planning option where you can put in an explicit alpha risk and an explicit beta risk for population size, and put in a tolerable deviation rate, and it will also allow you to calculate a sample size that way. Another question is, can one download a QuickBooks file into IDEA to do testing? Yes, you can. You can output the QuickBooks data into certain other media, such as a text file or Excel file, and then you can use either text import or the PDF print report reader to get the data into IDEA, and then you could perform these sampling methods on the data. Okay. If that's all the questions we have, I think that's everything I have.
Thank you so much, and thank you for joining us. Have a great afternoon.
Thank you, everybody.
If you come up with a question, you can always email Kurt or give him a call directly, and we can answer your questions then. Have a great day.